record on this computer. All right, for the sake of the recording, I'll repeat just a little bit. So here we have this little chart, and we can use it to go from any of 4 cities to any of 4 cities. And essentially what you're doing, if you want to find out, hey, I'm going from New York to Tokyo, is you bring your finger down here, oh, New York, there it is, and then you come across to Tokyo. So the basic idea here is using 2 numeric indices, you can find data in a 2-dimensional structure. And of course, the same would be true if we wanted to build a 3-dimensional structure. We could use 3 sets of indices. And it probably won't surprise you too much that in programming, we like to do this stuff a lot, because this kind of structure, this tabular structure, allows us to pack a lot of data into a very small space. And so we could use menus and arrays to go there. I'm curious exactly what link I have here. Oh, son of a gun. That's one way to do it in Java. And I think that is the approach that I gave you. So let's take a look at this program a little bit, and we'll see what it does. First of all, I'll just go ahead and run it. Let's make sure we're running the same one. I think so. Yeah. So I'm going to go ahead and run it. So we'll compile. And we'll run. So please select a city that I'm leaving from. So the origin is what? Where we're going to leave from? Let's do New York. And then where are we going to go? Let's go to Tokyo. The distance between New York and Tokyo is 6,760 miles. Well, that was fun. See, recently I went from London to Indianapolis. So let's see how that was. London to Indianapolis. 4,000 miles. Nice. Okay, so you can see it works, right? Now we'll take a look at the code. You like my little loop here? That's nice, isn't it? That looks familiar. So let's take a look at the code and see what we're learning about here. There's a lot of interesting things going on. The first thing we'll notice is heavy use of arrays. When we start to talk about a lot of data, we're going to end up using arrays. Now, most beginners, when they try to write a program like this, will end up using a lot of if statements. I mean, when you first saw this table, you probably thought to yourself, hey, I could use a ton of if statements to get there. And would that work? Yeah, it would work. It would work. But it would get pretty messy pretty quickly, right? With only these 4 cities, then I would have to have an if with 3 elif clauses and an else probably. So I'd need 4 if statements there, and inside each of those 4 if statements, I'd need 4 more if statements. So if I have 4 cities to deal with, then I'm going to have on the order of 4 squared if statements. If I have 5 cities, I'm going to have 5 squared cities, which is 25, right? What if I have 10 cities? Now I'm talking 100 if statements. Are 100 if statements going to be a pain to manage? You know, I've graded some of your work. Some of you had some trouble with 5 if statements. So can you imagine getting 100 if statements right, especially if they're nested inside each other? That could be a problem, right? It could be really, really messy. And so what we're going to do is we're going to think about, rather than making our code more complex as we're solving more difficult problems, instead what we're going to do is we're going to make our data more complex. And by having a slightly more complex, more carefully thought out data structure, we can often make the code easier to understand and easier to maintain, and hopefully easier to change, so that when somebody says, you know what, we should add Managua to this list, then we can easily do it. Because, you know, if you were doing if statements, adding a new city would be pretty painful. With the technique I'm going to show you here, though, it won't be painful. In fact, we should be able to just do it. So I've got a couple of arrays here. Now this one is in a format you're already familiar with. So it's basically a string array called city, and I've put in several cities. Now in this case, I'm pretty careful about the order because I want to be consistent that Indianapolis is always 0, New York is 1, Tokyo is 2, London is 3. If we want to put Managua in later, we'll do that. But for now, we'll just leave it like it is. Did not need that last comma, but it didn't hurt anything. Okay, so I set up that array of cities. Now this is crazy. This whole structure here is technically one line of code, and at first it doesn't make a lot of sense. But if you look more carefully, you might be able to see what's going on. Yeah, I'll try and put them both on the screen at once. Aha, do you see what's happening? That and that are really the same thing. So this is a way for us to put this table in code. And so if you look at it, it's a little bit crazy, but it actually makes a ton of sense what's going on. Watch and see what's happening. So static, and right now I'm making things static because I'm making my data available to any function. We'll just leave it like that for now. Int square square. So what is this? Well, this is actually, well, let me just show you. It's an array of integer arrays. What? Okay. Its name is distance, right? And that makes sense. Now, what is this? Is this an array? It certainly is. But how many elements does this array have? Well, it has 4. That's one element. That's one element. That's one. And that's one. So what this is this is an array of integer arrays. Oh, we can do that? Yes, we can. So we can have an array that contains arrays. And that is incredibly powerful. Because what I'm saying is, for each of the cities I'm coming from, basically each row of the chart, I can have an array of how much it costs to go to the other cities. So if I'm at city 0, Indianapolis, it costs me 0 miles to go to Indianapolis, 648, 64, 67, and 4,000, and so on. So this structure is incredibly powerful because it allows us to store an entire data table worth of data into only one variable. Now its structure looks a little weird because we have the 2 square braces. That's because it is an array of integer arrays. And then the usage of it is a little interesting too. Now with this guy, it's a single array, right? So element 0 would be Indianapolis, element 1 is New York, and so on. For this one, we need 2 indices because we need to know, first of all, which row are we talking about? Sorry, I'm losing my voice. And then which column within the row we're talking about. So whenever we're working with the distance array, we'll need 2 indices. All right, everybody good so far? We all happy? All right, good. The other main thing we'll do here to make this whole thing manageable is work with functions. So we're really getting into, programming style now, because what we're saying is our code is starting to get complicated enough that we need to compound the data and we need to compound the instructions. And that's the central idea of functions and arrays, is that we can put a bunch of functions together or a bunch of commands together to make a function. Remember that? The ants go marching in. The song just got out of your head and now I brought it back. Sorry about that. And to put a bunch of data into arrays or other complex data structures. So that's what we're really doing today, is just learning how to encapsulate our instructions and our data. So here's my main function. Our main function is nice. Oh, I don't know why my indentation got all messed up when I moved into this one. Let's see. I'm going to try it in another editor just to see if it was okay in that. I'm just curious. Okay, let's see. And that is called distance calc. Are these okay here? No, it got messed up there too. Okay. So I'm just going to make the indentation right, because sometimes when I switch from editor to editor, it gets confused. Okay, so that's all right. And that's all right. You do want to make sure your indentation is all lined up. Why is that? Well, it's a good indication that you understand what's happening. And if your indentation is not lined up, then you're likely confusing yourself. And I have seen that in some of the work that I've been grading. A couple of you that are having trouble, you have braces happening all over the place, and there's no indication of what ends what. So be very, very careful with this, because you can really confuse yourself. So now we'll look at this, and we have a main function. And the main function is pretty straightforward. Boolean keep going is true. Scanner input gets new scanner. Nothing shocking there. Now I have my old friend, the keep going loop. This is a really handy way to manage complexity. So now int from. So I'm creating a new int variable called from. And well, what happens to that? Well, we call the get city function. So apparently there's going to be a get city function. You could look up in Java, but you won't see that. There is no function for get city. So where does it come from? Well, I created it down here. There's the get city function. Oh, lovely. But here's the best part. I don't care right now. Right now, I don't care about get city. I just want to know that it does what it's supposed to do. And here's what it's supposed to do. I'm supposed to feed it like an origin or a destination. So I'm going to feed it a string. And then it will do some magic. And at the end, it will produce an integer. How do I know that? Because I'm putting its data into an integer variable. So what's really great about this is I don't care right near how I'm going to get the city. All I care about right now is there is something called getCity. If I pass it a string, it will magically return an integer that I can use. That's pretty exciting. And look at this too. It does the same thing. It calls getCity, and it gets a city, and it puts it in a variable called 2. Now, why did I put this in a function? Two very good reasons. One is that I don't care about the details of getting the city right now. That might change. And honestly, it doesn't matter to me how I get the city as long as I do. That's one real good advantage. The other great advantage of this is, honestly, I don't want to be thinking about those details right now. I want to have these two variables and then be able to move on to the rest of this part of my code. So I want to separate the problem of getting the city from the problem of solving the distance. Does that make sense? How do you solve a really big, complicated problem? Well, you break it into a lot of smaller, not so complicated problems, and you solve those one at a time. That's what you do. And so that's exactly what we're going to do now is we say, hey, there's really at least two problems. One is getting the city, and one is solving the distance. So for now, we don't even worry about getting the cities. We'll look at that as a different problem. It's very powerful. Now, that means we can't test this yet, but sometimes I would just throw some cities in there just to make sure. All right, so let's presume that we do have the get city working for now, and then we have this integer result. Now, this part is what's really exciting. Remember when we were talking about having to have 16 if statements? Well, all 16 of those if statements are then slammed down into this one line of code. Result equals distance from 2. That's pretty exciting. And so this is what that's doing, is this is going to that distance, which is this guy right here. And the first parameter is what city we're coming from. That'll tell us which row we're talking about. The second parameter is that where are we going? And that'll give us the cell within the row. Oh, so this one line and the data structure replaces 16 lines of if, else ifs. And so that's very powerful. And we could do a lot of work. Most of this code is just about formatting the output. The distance between, now I don't want to say, now from is an integer, right? It's going to be 0, 1, 2, 3. That's not helpful. So I'll just put in the city name so I can just pull that from the city array. And there's another call to the city array, is result miles. Oh, so there's a lot going on there, but it's very, very simple. We're basically just printing out strings and lookups from an array for that result. And then, of course, we want to see if they want to play again. So we'll ask them, do you want to play again? Now we're going to take that, put it into a try again string, convert it to uppercase, and then we're going to look at the element 0. So if they typed in yes or yeah or yep in uppercase or lowercase, all of that will count. So if first char is y, then keep going is true, else keep going is false, and we get out of the loop. Isn't that nice? Pretty nice. Now let's take a look at this getCity. So getCity is an interesting function because we can tell a lot by its main line. And in fact, if you were not given that city, if you just saw this line, you could tell how to build getCity, because you can tell some very important things. First of all, what's the name of the function? Well, getCity. Secondly is what sort of data does it return? Well, an integer. And what sort of parameters does it take? A single string. So just by looking at the way a function is used in code, you can pretty much guess exactly how that function will need to be defined. And big hint, that's going to be part of today's lab. So part of what you're going to do this week's assignment is exactly that. I'll give you some code. You're going to figure out how you need to build functions that will support that code. So here we are. So we can tell it's public because so far everything is. It's static because so far everything is. It returns an int. And we know that because we saw that we have to give it back an int. Its name is getCity. And it takes a single string parameter, which we will call prompt. The prompt is what it's going to print out. That's this part here. So when we ran it, notice how it worked. First it said origin. There's origin. And then it printed up this cute little menu. And then it asked for a city number. I typed in a number. And then we don't know what happened. But then we saw destination. Well, that's this one. It did almost the same thing. Printed out the cute little menu. Asked the user for some input. And then went on to the next piece, which does line 32 and beyond. So you can see that we were doing very similar code twice. That's a good place to maybe look for a function, is when very similar but not identical code is going to be happening more than once. Because you don't want to write that twice if you can just call a function. Okay, so let's take a look inside the function and see how that works. So scanner input gets new scanner, result is 0. Now system.out.println prompt. So, you know, that could make this as elaborate as I wanted. I could have said, where are you starting? And I could make this one, where are you going? Okay, we'll save it, compile that, and just see that those prompts have changed. Okay, let's see. Where are you starting? Oh, well, that's very handy. I'll go Indianapolis. And I'm going to London. That should be 4,000 miles. Boom, try again. Not on your life. And it stops because it doesn't begin with a Y. Okay, so far so good. So we can see that the prompt is being printed out. That's all that does. Now we print out this menu. There would have been a better way to make the menu, but for now I'm just going to live with this. This is fine. It might be better to make the menu dynamically based on that array. But this is okay. So there's my menu, and then I'm asking for a city number. I'm going to read in that input and then try to parse it to an integer. Have we done try and catch yet? Have we talked about exception handling?
Yes.
Yes. Okay, I thought we did. So why would I want an exception handler here?
Just in case somebody types a number or a letter or something unexpected.
How likely is it that something will go wrong right here? Extremely likely, so we pretty much have to have an exception handler. So my exception handler is going to be very basic. If I catch any exception at all, I'll just say something went wrong, and it's so at least it won't crash. Okay, now the other thing I'm going to do in this function is I'm going to look for some error boundaries. And I told you not to do them, so I won't do it. I'm going to change this whole thing right here because I told you not to use or statements. All right, I'll just change this code here. See if you can figure out why. What was that I had there? Okay. It looks like I'm actually wasting a lot of code. I'm wasting a lot of space here by putting code twice. But it's worth it. Okay, so let's take a look at what is happening here. Why am I doing line 79? What is this checking for? All right, how about this? What if they type in a 5? I want to go from city number 5. Is there a city number 5?
No.
No. And so it shouldn't try to keep going. It's gonna crash, isn't it? So what I'm doing here is I'm checking to see, hey, the result has to be smaller than the city length. The length of that city array is 4 elements, so if the result of this is 4 or greater, then I know they can't do that. So that's another error that wouldn't have been caught by an exception. Make sense? So I'll go ahead and say that is incorrect input, assuming 0. Likewise, if the result is less than 0, what happens if they type in a -5? I'm going to go from city -5. Well, that doesn't make sense either. So I'm going to try and do the same thing. Hey, you can't do that. I'm going to make it city 0. So these two pieces of code help me correct for errors. And this is one of the key ideas that we do in programming. I mean, you're already learning how to program. That's good. But we're also learning how to program well so that you're going to design code that tries not to crash. And so already here, we're talking about how can I anticipate user mistakes and have some predicted behavior happen if the user gives me some sort of crazy response. Now, there's other solutions. This is often why we like using a graphic user interface. So if they have to select the city from a drop-down list or press a button to choose the city, well, they can't get it wrong. But we don't know how to do that stuff yet, so we won't. If we're going with command line input, we have to have these tests in place to make sure that we've checked for what sort of things can go wrong. And of course, I have an entire class on exactly that when we talk about how do we look for various things that can go horribly wrong. But we're not in that class yet, so don't worry about it. The main thing is we think about what we can for now. And clearly being over the limit is a problem, and having a negative number is a problem. Having a string is a problem. So this is nice code. Now, you know what else is nice about this? Is that I changed it only once in the function, but did it change twice in the code? Yeah, because I just called the function twice. So now as you look at this, return result means that at the end of this whole complicated function, I am pretty certain that I have got a good integer value for result that I can use in the rest of my code. Oh, that's really nice. This style of programming is very handy because in the early time, I can just have, like when I'm just testing it, I could have the getCity function do nothing but say return a 2 or whatever, and I can test it that way. Then I can make it more sophisticated and be able to test it separately than testing my main code. And a lot of times I'll do that. I may do just test this function on its own to make sure it's doing what I want it to do before I use it in the main program. So does this work for you? Is this making some sense? Pretty good? Okay, cool. At this point, I think I want to go ahead and talk about the next assignment, just because it uses these ideas. And it does not require you to understand object-oriented programming yet, which is our next idea. So let's talk about this next assignment in some detail. So let's see this one. Okay, I'm showing it to you in another language just so that you can see it working. And so let's see, I want to, what do you want to do? I want to encode something. So this is a program that will send secret messages. So I'm going to encode a message. Java is really cool. Okay. And there it is. Yeah, pretty cool. All right, I like that. Rudupnej, I don't know. Should we write that down? Let's just do the first part. Rudu, R-U-D-U. Now I want to decode something to R-U-D-U, Java. Oh, how exciting. It worked. Would you agree? It worked. And that's pretty fun. Okay, let's say I want to quit. I'm out of here. So that's what you're going to write. That's what we're going to write. Here is a version of it running that looks more like what you'll see. So crypto machine, select an option. I'm going to quit. I'm going to encrypt or encode a phrase. I'm going to decrypt a phrase. And so we'll enter in one of these choices. All right, then it's going to ask, please enter the unencrypted phrase. Well, I'm going to do this one, Java rocks. And then it returns Rudufquen. All right, well, that doesn't make a lot of sense. Okay, so now I'm going to, it takes me back to the main menu. Now I'm going to decrypt a phrase. And so I'll paste the same thing in there, Rudufquen. And it returns Java rocks. So we put it in a secret code, and we were able to get it out of the secret code. It's not a very good secret code. There are much, much better encryption mechanisms out there. But this is a pretty good example of what's called a substitution cipher, which is a relatively easy cipher to write, and it's a pretty interesting problem. Would you agree with that? Sounds kind of fun in a weird little nerdy, geeky way. And finally, I choose 0, and it says goodbye. All right, so here is the good news. I am going to give you some starting code to work with. So you can take, and in fact, I want you to take all of this code and copy and paste it into your editor and save it as crypto.java. Why should you save it as crypto.java? Well, a couple of you have been getting sloppy about how you name your files, and Java will refuse to compile if the file name isn't the same as the class name. So be careful about that. All right, so I'm going to save this as crypto.java, and then, well, my goodness, it's all done, right? No. Then what you're going to do is you're going to have to analyze this code to figure out what's going on. I gave you one function, but you will need some other functions. So how do we know what functions we need? Well, we're going to have to analyze it. So let's begin. I'll begin by analyzing it a little bit so you can see where to start thinking. The first thing you always look for is, what's my data? I've got some good data I can be working with. I've got this input scanner. Okay, that's nice. Now I've got this string for the alphabet. That's pretty nice. A, B, C, D, E, F, G goes through Z. Notice I'm using only uppercase standard American English characters. That's to make your life easier. So once you get this working, if you want to do a version that can handle accents and Spanish characters, of course, that's wonderful. But let's not do it for the basic version because that complicates the code. I also have a key. And if you look at the key carefully, it is all of the letters of the alphabet exactly one time in a scrambled order. Okay, so that might be useful. Okay, then what do I have? Well, I have my main, that's fine, and my old friend keep going. And now take a look at this line. Response gets menu. Well, what do you suppose that means? Well, we're going to need a function called menu. And what do you think the menu function should do?
Quit, decode, encode.
It's going to print out the menu. It's going to ask the user for some input in a variable called response, and then I've done some work to compare response to other things. You have to analyze the main code to see what code you're going to have to write, so you get a pretty good sense of what that response or the menu function should be. Does it return a value? Yes. What type of value should it return?
String.
A string. And the string will probably equal 1 or 2 or 0. So that tells you lots of information right there. Does it take any parameters? No parameters, so that's good news. So now you know how to write that function. You have a lot of clues, and then you'll use those clues to actually write that function. Now, I've done a lot of the nice work for you for reading the menu. So if the response is 1, we're going to ask them for an unencrypted phrase. I'm going to call that plain. I'm going to convert it to uppercase because normally in cryptography you don't worry about upper and lowercase. You just convert everything to uppercase. And then system.out.println encrypt plain. Well, that tells us something new. What is going to have to happen for this line to work? We're going to need a function called encrypt. What sort of thing will encrypt return? Well, we're printing something out, so probably it's going to create a string. What sort of data is it going to accept as a parameter? A string. So now you have a pretty good sense. I'm going to have a function called encrypt. It's going to take in as a parameter a string, and it will return a string. We'll have to figure out how it does that and what it does, and that is, frankly, kind of tricky. Now we'll check this one. If the response is 2, then we'll do almost the same thing, but this time we're going to bring in code. We're going to call it decrypt. And we'll need a decrypt function. Can you write encrypt and decrypt at the same time? Now, and the reason is, once you understand encrypt, decrypt will be pretty right. Now, these are not simple functions to write. They are going to be tricky. People normally get a little frustrated here, but I'll give you some hints. Want hints?
Yes.
I thought you would. Okay. But let's keep going here. If the response is 0, then we'll just say goodbye. Now, I already gave you the code to handle anything else. So if they type in anything else but 0, 1, or 2, it just says, sorry, I didn't understand. So you are not allowed to change my main function. You have to leave this part just as it is. So you're going to take this, you're going to copy it, you're going to paste it, and then you're going to write the functions to complete this. Now, this seems like a silly exercise, but it turns out this is exactly how it works in coding workshops all the time. So I may write some primary code that's going to be a handler, and then I may, as the tech lead, I may give each of you a function or two that you have to write. And so I will say, okay, so here's my main function. It calls this function. I need you to write that function. It calls this other function. I need you to write that one. Now, if you're doing this, can you change the main code? No, because several of you are dependent on the main code. So you can't assume any changes. And that's why I've been a little mean to you, just a little bit, when you don't follow the instructions. I don't give you a great grade when your code doesn't do exactly what I say, because as you start working as a professional programmer, if you don't follow the directions your boss gives you, you will be working at a coffee shop. You will not be a programmer anymore, because they will fire you. And I'm just telling you, it's true. You've got to really follow the instructions well. Now, again, as you get to more advanced classes, especially testing classes in software engineering, we'll teach you how to be the boss, who's going to be the person who does that, who sets those things up. And then you'll truly understand why somebody who doesn't follow the guidelines you give them for these functions or whatever needs to be fired, because they're just going to cause a lot of problems. All right, so let's take a look at some hints. This is what's called a substitution cipher, and what it means is that every letter is replaced by another letter. I wonder how we're going to do that. We're going to use these letters as the letters and these letters as the key. So if I were to write ABC as my plain string, what would be the response? How would we encrypt that? UBW. You see that? If I said MMM, it would be LLL. Everybody good on that? And if it's Andy, ANDY, if that's the input, the result would be UCKT. And if I wanted to unencrypt that, UCKT, U should become A, C should become N, K should be D, and T will be Y. You see how that works? So that's what you're going to do, is you're going to write code that can do that. All right, so what else are we going to do? Think about spaces, punctuation, and other characters. There are several responses, but the basic response, and the one that I'm going to require for now, is that you ignore any spaces or any other characters than these. So if you see a space, if you see a comma, if you see a quote mark, if you see question marks, and so on, ignore them. Why would we do that? Well, there's two reasons. One is we don't want the bad guys to be able to guess. And so if you have an apostrophe, that makes it much easier to figure out what the next letter is going to be. If you have uppercase and lowercase letters, you might be able to guess that a word with an uppercase letter is the beginning of a sentence, or it's a proper noun, and that would give you clues, right? So we don't want that. The other reason is it's just easier. So your code is going to be easier to write if you don't have to worry about all these exceptions. So what we're going to say is they can type anything they want, but we're only going to encrypt these characters, and we'll ignore any other character. Okay, let's see. So capitalization, again, we've already talked about that. Methods. You can't change main. You can't just put more code in here. The whole point is to write new methods, and you saw that that was useful, right? When I had new methods, that simplifies my code. So you're going to have to make how many methods? 3 that we know of. Maybe more, but I think 3 is pretty obvious when you look at main. So for each function, figure out what you need and then make it. If you want to do a black belt, which you should not do until the main is working, then you can change main. But in your main version of the program, in your basic version of the program, do not change main. Each of those methods might require some parameters to be passed in and some return value to come out. And part of your job is to figure that out. All right. And we're just going to use the key that I gave you for now. If you want in a black belt to do a more sophisticated key, that's fine. But for the basic version, we're not going to. Now, we really want to think about string methods. Have I talked to you about how to work through the Java API? I think I went over that, right? Yeah. And so you're dealing with strings. And so since you're doing a lot of work with strings, you may want to look up in the documentation the string object, and you make sure you understand its methods. It has some very powerful ones: length, character at, and index of. Those are worth looking up because they might tell you some very, very useful things you may want to do. Now, I know I just talked about arrays, and you may be tempted to work with arrays in this whole thing, but that's far more complicated than you need. You don't need arrays yet for this one. Just strings are fine. And make sure that you go through the string object and make sure you understand what these methods do, how to use them, and what they return. That should give you everything you need to know. Of course, another talk here is this encryption is really bad. If you're going to be creating, your criminal, your crime syndicate with this or something, don't do that. If you're sending secret messages to your agents in the field, don't do that with this because anybody could figure it out. This is not really good cryptography. If you have a secret recipe for chili or something, don't put that in here because they'll find it out. Of course, you're going to have to test it. Now, I'm going to encourage, when I write this, here's how I test it. As I say, well, the first thing I got to do is just make sure the menu is working. So I would comment out this line temporarily and this line. Write the menu function and see if that part is working, because my code will handle a menu pretty well if the menu is written right. And then what I would do is then I would uncomment this line, so I can now have the encrypt function and write out the encrypt function. When I do encrypt, I would begin by just creating the function and then write out all of the algorithm. Remember how we talked about the algorithm? Ask the user for something, do this, do this, do this, do this. But don't write code yet. Make sure you write the comments first to have an idea what it is you're trying to say. And then once you're clear that your algorithm all makes sense, then you go back and you convert that to Java code. You got it? You got it. Okay. So that's the basic version. There's lots of black belt options. One is experiment with different kind of encoding techniques. So there's 100 different kinds of ciphers you could try. Vignere cipher is common. Caesar cipher is too easy, but that's fine. It's called column ciphers. There's so many different variations that are pretty cool. So you can play with a different kind of cipher or encryption. I mean, you could look at some libraries to implement some other more modern encryption techniques if you want. Or you could do this, you could create a new random key. That's interesting. So, the big weakness here is that the key is well known. So you could write a function that creates a new key. That's an interesting problem, but you will discover another problem. So see what happens when you do that. You will find out there's another problem with this, so you'll want to think about that. Okay, does this all make sense to you?
Yeah.
Yep. You feel like you know what you need to do next?
No, a little bit.
A little bit. Okay, a little confusion is fine. Hey, one more thing that the university asked me to do today was make sure you go to this link. It's a SurveyMonkey link, and they need you to fill out some kind of survey. So I don't know exactly what it is, but make sure you go there and do that to make them happy. Because when they're happy, then they're nice to me, and then I'm nice to you. So it almost. You guys doing all right?
Yeah.
All right. Keep up the great work. I'm really proud of you so far. You guys have a good day.
Okay, thank you. Hey, good question.
Watch for this video to be up on the site in a few minutes.
No. Yeah, there's the laptop.
Did you get my email?
I think I did. Which email was that?
Remember I was late on the change maker on the black belt, so I
didn't count anybody late on the change the change maker because of that whole being hit by a typhoon thing.
Yeah, but I sent it through an email, so.
Oh, I might not have seen it on an email.
How you been sent to get this?
Because what happened is that I got into Blackboard to look for the submission option, but I didn't find it. So I tried to send it through an email to your university.
Yeah, I probably didn't get that because I get about 100 of those emails from different students every week. So I probably didn't. Can you still put it in Blackboard?
Where is it for the submission? No sale, tiene que empezar notificaciones para change maker. If it's under notifications, no va a salir because it's overdue. The thing is, Mr. Harris, your change maker submission cannot be found in the regular week page in Blackboard. The only way to find it was through the Blackboard notifications. That's where I uploaded it.
Oh, it wasn't available through Blackboard itself?
I'm sorry? Hello?
So the change maker, you couldn't get to it the ordinary way?
Yeah, no, not the ordinary way, or like 2, 3, 4, and the only way we could find the assignment was through the notification that told us that it was ready to be submitted.
Okay. Well, that's weird. Where did it go?
And another question to ask regarding the submission dates, like, the previous project, when should we be submitting it?
I'm sorry, I cannot hear you very well at all.
The guessing game, when should we submit it? That's for this Friday.
Oh, the guessing game?
Yeah?
What about the guessing game?
What is it due this Friday, right?
Yes.
And this new one is due next Friday?
Yes.
Alright, sounds fair. Sure, that's all from me, thanks.
All right.
So,